We estimated this regression equation in Part 1 video. Beta coefficients estimated using 50 observations of data from an ice cream company. The coefficient of price suggests that demand of ice cream is elastic. An increase in price of $1 will decrease monthly revenue by $5,746. Or, in other words, if management announces discount in price by $1, monthly revenue will increase by $5,746. Likewise, an increase in advertising expenditure of $1,000 per month will increase monthly revenue by $3,000. We can use these estimates for prediction. For example, as shown here, for a price of $3 and advertisement of $12,000, the predicted monthly revenue is $127,000.
It is important to emphasize that regression beta coefficient estimates are called point estimates. They are estimated from a single sample of data. For another sample from the same population, these estimates could vary. The question is how much reliable these estimates are in terms of sampling variability? To answer this question, we have to obtain variability measures of the regression. Let's discuss two important such variability measures. First is known as the standard error of the regression, and the second is the standard errors of the beta coefficients. Have a look at the estimated regression equation. Estimated y values and the estimated beta coefficients are usually distinguished by putting hat over them, as shown here. In matrix form, y hat vector is equal to the x matrix multiplied with beta hat vector. The ones without hat are observed sample values drawn from the population. This is the representation of original observed y values in terms of original population beta coefficients. However, population beta coefficients are unknown.
Now, let's turn to the concept of error, a fundamental idea at the heart of econometrics. Although the terms error and residual are often used interchangeably in practice, there is an important theoretical distinction. The error refers to the deviation from the true but unknown population regression hyperplane, making it unobservable. The residual, on the other hand, is the difference between the observed value and the predicted value from our sample regression, and is therefore observable and computable. The observable counterpart of the error is known as the residual, while the terms error and residual are often used interchangeably in practice. There is a subtle distinction between them. Formally, an error is defined as the difference between the observed value of the dependent variable and its predicted value, that is, y minus y hat. Let's calculate what's called the error sum of squares. We square each error term and add them up in matrix form. This is the dot product of the error vector with itself. Mathematica estimated it. 1571.46. We can double-check it in EViews. Yes, it is the same. Degrees of freedom mean how many values are free to vary. Here we have 50 observations and 3 regression parameters. So 50 minus 3 gives us 40. 7 degrees of freedom. Variance of the regression, sigma square, is equal to error sum of square divided by degrees of freedom. And standard error of regression is square root of sigma square, which is 5.78. We can, again, compare it with output in EViews. Yes, it is the same. In Part 3 video, we'll continue with standard errors of regression coefficients and testing of hypotheses.